Test, test, test. There it is. Hi, I'm Scott Hanselman. This is another episode of Hanselminutes. Today I'm talking with Don Syme. He's the designer and architect of the F-sharp programming language. How are you, sir?
Hello, Scott, and lovely to be on your show. I'm extremely well. Thank you very much. Always a pleasure to talk to you and see your smiling face.
It's very nice to see you. I think the last time we saw each other in person, we were having a burger in a pub in Portland, Oregon.
It's right. One of really my favorite city in
Yeah, it
America,
is lovely.
certainly,
That's
and
why I'm here.
somewhere I used to live and have a very real soft spot for.
I appreciate that. So, F-sharp, I think, is having just a lovely last couple of years. A lot of people are talking about it. And, I was mostly familiar with F-sharp 10 years ago when F-sharp 2.0 came out. And my kind of first impression of it was, okay, it's a functional language for .NET. It has roots in OCaml. There's Haskell bits. And I thought that it was there's C# and there's VB and there's these imperative languages and then there's these procedural languages and then there's F#, which is the functional one. But I'm told that since I haven't looked at this in a number of years, that my impression may very well be quite wrong.
Yeah, it's an interesting thing. When we first did F Sharp in sort of F Sharp 1.0, we actually didn't talk about it being a functional language very much. Okay, because what matters to me is not functional or not. C Sharp supports functional programming, Python does, JavaScript does. A lot of different languages support functional programming, and that's not that. It's not a religion. What we care about is what we deliver to programmers. And it's always been the case ever since the very start of F Sharp, as we cared about delivering simplicity. And there is something incredibly simple about a data-oriented programming language where you can just say, let data equal the numbers from 1 to 100. Just like, and you just give me that data and then work with that functions and transform that kind of data. Or so, give me my inputs and start transforming them. And so we care about simplicity, but we care about succinctness, but we don't want to trade off with correctness and robustness and performance. Okay, so we want that strong typing, we want the succinctness, and we want the performance that comes with those characteristics. Now, the strongly typed functional programming languages are the only languages which deliver on all three of those. If you're a Python programmer, you get succinctness. You don't get the robustness and the performance that you need. If you're a C# programmer, C# getting better, but you get the robustness, to some extent the robustness and the performance, but you don't get that kind of succinctness. And so F# is really that sweet spot where you get all of these things at once. And it is because we deliver on this practical, strongly typed, highly type-inferred, data-oriented kind of programming experience. So it's always what F#'s been about, and it's what F# is about today. And so you'll see us emphasizing those things about F# going forward. If you go to the F# Software Foundation, fsharp.org, the homepage for the Software Foundation and for the community, you'll see F# empowers everyone to write succinct, robust, and performant code. And that's what matters to us.
So that word succinct, like I know that when we are programmers, names matter, and people will sit around and argue about the class of an object and make sure that the word is right. We'll get thesauruses and we'll find code words and we'll look back into dead languages to get the right word. So that means that you didn't just think about, we could have said short, we could have said brief, we could have said concise, but we said succinct, which means to be briefly and clearly expressed. You thought about that.
Exactly. We don't just make code shorter for its own sake. In fact, you want to use the relative succinctness of F# code to bring out other qualities of software, to give good names to software, to give good documentation to software. So just because F# is kind of looking after the whole business of looking after all your types by doing great type inference, just because it gives you these wonderful constructs for correct programming like async programming or computation expressions or computed lists and all these amazing constructs that it has, then that allows the logic to be of your solution of your program, data plus functions normally, to be expressed really beautifully, really clearly. So many people comment on how clear, well-written F# code is. And so, yeah, it's all about delivering clarity and delivering clarity in the context of teams who are using it. F# is designed to be a functional language, a succinct, performant, robust language you can trust in enterprise situations where you have whole teams of people cooperating and sharing on this kind of code. And so that clarity is what it's all about. Clean code, clear code, while still being robust and performant. And yeah, absolutely deliberately chosen word.
Yeah, yeah. There is a deliberateness in everything that both you do and that the team and the community does. I also want to take another word and go a little deeper because people who are listening may have different backgrounds, where some may have gone to computer science, some may have advanced degrees, and some may not have a background in either math or computer science, but may still be programmers. The term correctness is something that you've worked on in your career when we're talking about the correctness of a program or a system. What does that mean? It's more than just being
Yeah.
right.
Yeah, no, I mean, so we talk about F# being a great language for writing correct code, and let's map that down to some language constructs. So many angles to this. But one of the key things, let's take two language features which everybody listening from the C# world will be very familiar with, which do not help with correct code. The first of those, of course, C# is doing a lot about this, but it's still kind of lurking there everywhere, is nullness. Okay. So when you have nullness, whenever you get your input, it might not be there. Okay. It's just like you just take this podcast and randomly chop words out of it and put beeps in the middle of it. It becomes quite a lot harder to understand. Or just replace them with crashes where the thing pauses and fails. Then everything. You must rely if nulls corrupt the reliability of the program's experience of working with information. It means that they've got so many extra cases to deal with, and there's just failure conditions all the way through code, and it is absolutely a disaster for writing correct code. Code that, for instance, and you can measure correct code just by the number of bugs on deployment, and people using F#. I mean, you don't always, of course, F# code has bugs, but we have had plenty of examples of project deliveries with extremely low bug counts, or delivery to production with zero bug counts and the like. And that's it's anecdotal, but the people who use F# deeply in enterprise situations absolutely value it for its tightness and its writing correct code. But let's take another feature in C#. When you evaluate a statement in C#, put the semicolon, and let's say that thing produces an object. Okay, C# will implicitly throw that object away. Okay, it will sort of just discard that object and then you return from your method. F# won't let you do that. Okay, it won't let you just throw information away. You'll have to go ignore. In fact, it's a case where F# is less succinct than C# because you have to explicitly ignore. If you produce data and you don't use it, you've got to ignore it. Okay, and this is one of and there's similar things on the tightness of inputs. If you add information into your objects coming in, you've got to bookkeep that. You've got to use that information. Okay, you've got to say, at least in certain, so there are, and it depends on the language construct you're using in F#, but there are these language constructs which effectively require, if you extend the information, then you've got to go through your code very quickly because it's all strongly typed and it shows you all the places that need to be adjusted. And you've got to account for the information. And so what this means is you get this tightness of code that where you make an adjustment to your domain model, and then at every place you kind of consume that, produce or consume that domain model. So on the producing, it doesn't let you just use null. You got to fill that in. All the places where you consume it, you've got to fill that in. And that gives this end-to-end tightness. It applies only to certain language constructs in F sharp, but they're quite fundamental ones: discriminated unions and records and tuples and so on. The tuples are tight. If you add something to a tuple, you've got to go through and bookkeep it all the way through. And so this is very core to a lot of F sharp programming. These kind of tight features are strongly emphasized in F sharp. And that means it gives you this tightness, correctness, robustness property. It's hard to make adjustments to F sharp code that lose information where it shouldn't be lost, or accidentally produce empty, null kind of information where it should be filled in. And this is wonderful end-to-end properties of the software.
Mm-hmm. So someone online, an F sharp person, Yaron Minsky, said F sharp's type system helps you make illegal states unrepresentable. So it's so intentional that it's trying to prevent you from expressing an illegal or an invalid state. And you're proposing that some other languages may, in fact, make that a little too easy.
Oh, absolutely. That's a key mantra on the domain modeling side. There's a wonderful book called Domain Modeling Made Functional. It's also it's by a guy called Scott Wolashan, and it uses F sharp as the domain modeling sort of to teach a range of domain modeling techniques. Some of those techniques can be applied in other languages. Many of them are strongly associated with the kind of data and functions kind of view of programming where F sharp is kind of coming from, and strongly recommended for anyone writing software in C sharp or F sharp, or anyone interested in software of any kind.
So back in the day when I started in assembler and in C, I was allocating my own memory, and I was thinking about registers, and I was, keeping track of stuff. There was an intentionality to it, but the intentionality that I was expressing in my programming language was intentionally adjusting the physicality of the processor, the physicality of the RAM, rather than the physicality of the domain model. I'm hearing you say that you have to keep track of things, and F sharp doesn't let you be lazy, and you can't just make an object and let the garbage collector clean it up. You have to be intentional.
Oh, well.
How is that intentionality different than the kind of back of the days of old?
So to be clear, F sharp, you can do what you just said. I mean, we have a garbage collector, and in fact, you can. It's not that you have to explicitly deallocate information. It's more that if you add something to your domain model, you have to kind of use that information. It's more about an information flow kind of problem. The intentionality is in the focus is on some domain, some model of the information in that domain, and that sounds abstract, but what that kind of means is you've got web requests coming in, and you map them through to types which contain the information in those web requests, and then you go, well, okay, serving this web request on my server side means getting this information. I get some more information and go get this information more, and then I've got to mix those sort of things, and then as that, so you solve your problem, and then more requirements come in. And you get a bit more information from one backend service, and then a little bit more from another, and you go, and we no longer get this information, and you're made to adjust. So as your requirements evolve, your software maintains its tightness under change.
Okay. One of the other things that's fundamental about F sharp that makes it attractive to people and allow the code to behave more predictably is its insistence upon immutability. But I also know that performance is like super high on the list there. And I have heard sometimes immutability and performance are at odds.
They absolutely. So, I mean, immutability is about domain modeling. It is about correctness as well. If you're able to use immutable data and you represent the inputs to your web requests or data you're getting back from various backend services, it's kind of immutable. And then eventually the final collected result can be immutable and then handed back, serialized back in some kind of response to what you're implementing. Or in fact, if you're on the front end and you're representing the model beneath your UI, it's actually for a lot of UI programming, it's perfectly reasonable just to represent that as a piece of relatively small functional immutable data that represents the kind of collected inputs or collected state of where things are in the UI, and then you have a view which you can render based off that. It's a very common technique, sort of like it's used in React and other places. Uh, so these days, there's a lot of CPU around on machines, certainly for UI and certainly in the web. Large parts of the kind of information bookkeeping kind of problem, the data load pipelines, absolutely very large parts of those can be written using immutable data. Often there's a core activity that needs mutable kind of your dictionaries or needs your big arrays of information. Sometimes that goes to an extreme where there's kind of one as a server or machine learning process or something like that that has fills up the entire memory with one massive array that gets mutated by everybody. Okay, so there's absolute and F# can totally be used for that, and you can do mutable data, no problem at all. You get all your .NET types. You can absolutely go in and just the defaults are immutable, but you can drop down to mutable whenever you need. That's often why we use the word functional first for F#. Not because it's kind of you start with immutable data and functions. And when we say functional, we don't mean we don't mean a lot of stuff that often gets associated with that. We just mean the really simple stuff: data and functions. You got data, and you got stuff that transforms that. That's it. That's all the it's like really kind of simple version of functional programming, and then but really well tooled and equipped to support that mode of programming.
And in F#6 coming in the future, that all of this is going to come together into really, really high performance and also asynchronous.
Yeah, we've got some
workloads.
interesting features coming up in F#6 in terms of performance. So F# has always supported async programming. It works very beautiful as a programming model. It's the programming model that inspired async await in C# and then in Python and the whole, all these, nearly every C++ now is all sort of flowed out. And I'm, of course, incredibly happy to have played a part in that kind of history of the development of sort of this. What I think of when I think of async await, I kind of think of it as like a mode of your program, a modality. You might use a fancy word. Right, but the F# async implementation was relatively early in the history of async and has some performance issues and some debug issues. And a lot of those got ironed out in C# async await. And we are now through what you think of as the task modality, I guess, in C# async. And we will now have, it's just one little construct in F#, task, curly, and it compiles down to this very beautiful, debuggable, extremely high-performance code, essentially the same code you get out of C#. It actually uses a very general feature, which is called resumable code in F#. And you can use that feature to do not only tasks, but also asynchronous, async enumerable in C#, asynchronous sequences. And you can actually do a whole range of other constructs, which the C# guys have to go and the C# team have to go and build. Sorry to use the gendered word of there, not guys. Who know? I shouldn't.
I say folks myself.
Folks, yeah. The C# team will go and implement all these different things in the compiler. We can do a lot of these things in the library, but the end result is F#6, which is sort of just in the planning process for .NET 6. Is going to have this hyperf task support. F#5 has had loads of wonderful features as well. But we also did a really interesting hyperf immutable data feature, which is, so there's a very common thing in F# where you generate up lists or arrays of data, and then you don't change them. But you write a bit of code which is saying yielding, yield this one. Think about it a bit, or do a calculation and then yield 1 or yield 2. And you use this for user interface views, and you use it for all sorts of programming problems drop out really beautifully with this. So we did a hyper version of that. F#5 had a lot of work on struct and span. make sure you could use struct representations of these F sharp constructs. You could just put the struct attribute on a record and it becomes a higher performance. Struct tuples and all sorts of other things we've been doing. So there's been a running theme all the way through F sharp 4.6, 4.7, 5.0, 6.0 of making sure F sharp has super good performance characteristics.
Mm-hmm. And now that F sharp is growing and evolving in a time of the cloud, I want to take two cloudy things that F sharp really seems to be well positioned for. First, there's things like data. You talk about data pipelines, things like Apache Spark seem like obvious things that F sharp get involved in. And then Azure Functions, right? You've got this succinct, performant, functional language, and then you've got serverless functions in the cloud. Peanut
Yeah.
butter and chocolate, put them together.
Yeah, it's. I mean, the end to ends that we see the people using F sharp in enterprise situations creating are just amazing. Sometimes they will use Azure Functions as the hosting for the endpoint, and the code will just be data coming in, request data coming in, a whole bunch of this kind of functions and data kind of programming, handing off to backend services, and then coming back with the request. And Azure Functions has a real beauty and simplicity. And there are good guides out there to getting started. There are template sets and the like for using Azure Functions with F sharp. With Spark, again, I mean, what I am so excited about is that we have solved the big data problem for .NET, and not just C sharp, but also for F sharp. And that is been, I mean, if you go back through the history of people doing big data systems of some kind or another, you will, it has been a pain point that .NET hasn't played in that space when it has all the right characteristics to play beautifully in the big data space. But those technologies were always dominated by Java. But the great news is for .NET programmers today, whether using C sharp or F sharp, big data solutions exist in the form of Apache Spark for .NET. And there are F sharp samples on the homepage if you go to the repo, and they're easily enough to get going with, and you can bring up your Spark clusters in Azure and scale everything out, and it's absolutely beautiful that that stuff is coming together. Now, the cloud is a funny thing. The way I think about it, when you and I did programming, you had a machine. When we started, you had a machine, and then you started coding, and then there was like this infinite universe of creativity and code that you could do, and it was code all the way up. Okay, and it's like a beautiful island in where everything was sort of growing and building, and it's sort of like playing SimCity or something, right? The cloud's a bit different, which is that the system dominates. Okay, this thing, you're not on your local machine, you're on this thing which is like 100 data centers around the world, all connected. This massive machine, and programming is made up more of these bits of program that you inject into different parts of this system. Okay, different services that kind of connect, and different, you might be handing off, in the case of Spark, you're handing off relatively small packages of code, maybe sitting on a library base and giving them to Spark, and it'll run them on those clusters for you. And that thing about the cloud being more like big mountain ranges with bits of code in between. It's the way I kind of think about it. There's a different mindset to programming. And so it's really crucial that your programming language be able to live in that cloud, that you have these services which allow you to take your F sharp or .NET in general and get them into Apache Spark at the performance level kind of required. So I'm very happy that we've got support for that.
The other side of the cloud is the clients, which are, as you pointed out earlier in the chat conversation, have far more CPU, far more GPU, far more capability. Even the Pocket supercomputer that I have in my pocket has a quad processor and 8 gigs of RAM. And we're running a lot more JavaScript than ever before. And JavaScript may not necessarily be the language that we deserve, but it's the language that we have. But F sharp seems to be breaking out of not just being something that runs in the .NET runtime. It can target other runtimes.
Look, absolutely. F Sharp is a JavaScript language and a .NET language. And in this way, it actually really is very different to C Sharp in that the F Sharp community provides the JavaScript support. Take the JavaScript experiences with F Sharp extremely seriously. We design the way we think about DSLs is to make sure you can do good HTML DSLs and things like this in F Sharp. And I will use, I know we're coming up to time, but we have and I'm not sure when this is going to be coming out. Will it be coming out in the next day or two or before?
I think I'll put it out on Thursday. So if you're
Great.
listening
I
to
am.
this, then you're listening to it after the 29th of July.
Okay. So, coming up when we're recording this is .NET Conf Focus Day, a fantastic event full of F Sharp content. It probably will have been held by the time this pops out, or maybe it's coming out on the day of .NET Conf Focus Day. And one of the things I got to do at that event was to spend time with Guido van Rossum, the designer of the Python programming language. And he was actually using F Sharp as a JavaScript programming language and a .NET programming language without actually having really needing to know which bits were compiling to JavaScript and which bits were compiling to .NET, because it is actually extremely seamless. F Sharp has a very good existence on both sides of the client and the server divide. And we also can do Blazor. We can do WebAssembly. There's a thing called Bolero, if that's what you're into. But the JavaScript existence of F Sharp through the Fable and Web Sharper compilers for it is absolutely superb. And it really lets you, as a programmer, use F Sharp as this sort of all-purpose tool right across the spectrum. And crucially, on the JavaScript side, you are living in the Node ecosystem. You can use .NET packages on the .NET side. On the JavaScript side, you can use Node packages, and you can use npm as your package manager. A lot of things flow across very nicely from the JavaScript world. F Sharp is effectively playing the role of TypeScript on that side. Of course, you can use TypeScript instead on the client side.
Mm-hmm. So you taught the creator of Python your language, you, the creator of F Sharp.
I got to do this. Yes, we recorded the session, and it was Guido's suggestion as for how we spend the time together. And I must say I was really happy with how this session went. F Sharp is an extremely simple programming language in many ways. It's simple to learn if you're given the right learning samples. And I think it often seems to, from a learning path point of view, it seems to work best if you're given some working F Sharp that does something useful, and then you start to fiddle with it and adjust it. Partly because the tooling helps you, partly because the strong typing helps you, partly because it kind of guides how simple it is to work with the language from that point of view.
Did you find, as two language designers sit together, like when language designers hang out, is there shorthand that you're using? And was he able to grasp things that you would have found if you had taught me F Sharp that would have taken me hours?
No, he grasped some things immediately, which I was very pleased with. I was very keen for him to understand how these computed list expressions work in F Sharp, because they are a very powerful construct. And they're more powerful. In fact, they kind of subsume about 3 or 4 C# features, which kind of feel very different. And they would make a good feature for Python 4 or 5 or something like this. I'm sure that got him thinking. And so I was very glad he used those and immediately got the feel for how they worked. And not only how they worked from a technical point of view, but why they're important in user interface programming. You'll see that in the recording for those who, if you've missed it, it's be online, and there'll in fact be a longer session available online as well.
Fantastic. So what I'll do is I'll find the F Sharp samples for Spark, the F Sharp samples for Azure Functions, the .NET Conf Focus Day videos, and the conversation with you and Guido, and I'll put them all in the show notes. So if you're listening to this show, just visit the page and we'll have all those links right below.
Absolutely. And the Getting Started material that took Guido through is available as a coding dojo, and we'll pop in a link to that. And get in and write your first F# as JavaScript, write your first F# as .NET, make yourself a little web application. And in fact, it's a one-line deploy through to Azure. We didn't do that with Guido, but it's just they're literally like .NET build deploy or something like that. The instructions in the getting started material, and enjoy.
All right, absolutely brilliant. Thank you so much. I've been chatting with Don Syme, creator of F#. This has been another episode of Hanselminutes, and we'll see you again next week.